Welcome back, everyone. This is the CBEST Practice Test, the mathematics version. So there are, 50 questions in this test. Okay, let's start with number one. There's a student that has some scores, and they want to know the average. Average is basically adding them up and divide by how many you have. Okay, so let's add them up. No calculators in this class, in this test. So you're going to have to use your fingers. That's 6. 7 plus 7 is what? 14 plus 1, 14, 15, right? Now, I'm adding this my way, okay? If you have a different way, by all means. 9, 8, 9, 10, 11, 12, 13, right? And that's 23. 71, that's a 10. That's 10, 11. That's 3. 80. That's 390. And again, this might be going a little too fast. You can always go 0, 9, and 3. The idea here is looking at different ways of doing these problems. That's an 8. So that's what? 14, 15, 16, 468. So 468. All right. So 468 divided by 6, because we have 1, 2, 3, 4, 5, 6. So we divide 4, 6, 8. 4 goes into 46. How many times? Well, 6 times 6 is what? 36. 6 times 7, you add 6 more. 36, 37, 38, 39, 40, 41, 42. That looks right. 42. How many times? 7. That's 48. And 6 times 8 is, that's right, 48. Is it 42? Yes, 48. So it's 8 times. So 78 is the average, and here it is. Okay. You have an answer key that you can always check to see if you got the right answer. This one is a little bit harder just because you're adding a bunch of numbers. Okay, let's do the next one. Next one says use the table below to answer. You have these, you have the totals, correct. On the 3 sections of the math, okay, answer the questions. What percent of questions on the entire test did the student answer correctly, right? Correctly. And these are the numbers correctly. So basically it's a fraction, right? The total will be on the denominator, and then this will be on the top. And that will give us what percent, which is a fraction. So 20 plus 15, let's do it this way. 20 plus 15, 5, 35 plus 25, 10, 60. Okay, so 60 is our denominator. And then 17 plus 11 is 8, 28, and then 20 more is 8 is 48, 48. You could divide this and then try to figure out what the percentage. I think it's better to reduce, right? You can probably reduce it by 12s. 12, 24, 36, 48. 12, 24, 36, 48, 60. I only, because I know my multiplication tables, I kind of was able to do that. 4 or 5. 48 over 50. You could divide by 2s. 2 goes into 48, 24. 2 goes into 25. 50, 25, right? And then you got to find a number that will go into it. Let's see. 2, right? 2 is 25. See, I already messed up. 48 over 60, sorry. 2 goes into 48, how many times? 24. 2 goes into 60, 30. 2 goes into 24, 12 times. 2 goes into 30, 15 times. 3 goes into 12, 4 times. 3 goes into 15, 5 times. You see that? And that's 4 over 5. And then you can say 5 divided by 4.0. Put the point here, now it's 40. 5 goes into 40 8 times. So the answer is 0.80 times 100 gives you 80%. 4 over 5. Another way, so that's the answer. One way of 4 over 5. If you know 1/5 being 20%, you know, a fifth of a dollar is 20 or 20 cents, 20%. And so 2/5 would be 40%. And 3/5 would be 60%. And 4/5 would be 80%. So that's another way of thinking about it. Okay, so this is, you can barely see it, but it's a bridge. Okay, you should have your own copy. And you'll find out that it starts here in the measuring and it ends here. Okay, this is something that you need to pay attention. The ruler doesn't start at 0 here, it starts at 1. So that's the trick. If the actual length of the bridge is 4,200 feet, so from here to here is 4,200 feet. Do you need to know what feet is? No, just it's a unit. Of course, most of us know. Then what is the scale of the diagram of the bridge? Meaning, and if you don't know what that means, look at the answer. 1 unit is how many feet? So there's 1, 2, 3, 4, 5. See? 1, 2, 3, 4. No, right? There's 1, 2, 3, 4, 5. So there's 5 units. 5 units goes into 42. Well, let's see. We can do it this way. 5 goes into this, right? This is 40. That's 8. And then this is 2. Then 0, 20. Gives you what? 4. 0, and then another 0. Okay, so 840, here it is, 840 feet. And if you want to make sure, you can say 840 plus 840 plus 840 plus 840 plus another 840. Does that give you 42? And it does. All right. So the trick is be careful over here. All right, number 4. What is which of the following is the most appropriate unit for expressing weight of a pencil? So you're going to need to know what's going on with the units. A pint is for liquid, so is quarts. So you can eliminate that. A ton. You ever heard of a 2-ton truck? So we're not measuring trucks. And pounds and ounces. Now pounds is like watermelons. It's 10 pounds. So we're not weighing watermelon. Pencil, oh, it must be ounces. How many ounces are there in a pound? Do you remember? Yeah, 16. Okay. All right, is that right? 4B? I think so. Okay. So this one, a teacher has a rope. She has 32 students, and she gives each student 5 feet, 8 inches. How long is it? Total. So we're going to have to, what I like to do is convert everything in inches. It'll be easier, and then I can multiply it with 32 and then reconvert it. So 5 feet, there are 12 inches for every foot. 12, 24, 36, 48, 60. Plus another 8 inches is 68 inches. So 68 goes here. 8 times 2, right, is 16. And then 8 times 3 is 24, 25. 6 times 2 is 12. Don't forget the placement here. 18, 19. 6, 7, 8, 9, 10. No, 9, 10, 11. 21, 7, 6. These are in inches. So I need to divide this by 12 to get feet. So 12 goes here 1 time, right? So these are all 100s. That's good. We're going to borrow 1, 2. That's a 9. That's a 0. That's a 7. 12, 24, 36, 48, 60, 72, 84, 96 is an 8. That's a 1, that's a 16, and then a 12, right? Now here's 18, meaning that none of these will count. 1, 8, 1, 8, we just need the next number. 12 goes into 16 ones, and then you get a 4, remainder, 4 inches. So 181, and then 4 inches. Boom, done. Okay, this one, use the following diagram. What is the total length of Clear Lake? The total length, the circumference all the way around. So to do this, let's see, 1, 2, 3, 4. So this is 2, 4, 6, 8, 10. So these are by 2 miles, right? Each of these things are 2 miles. And over here, 2, 4, 6, 8, 10, also 2 miles. These squares are considered 2 miles. So I'll start over here. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, right? 32, 34, 36, 38, 40, 42, 44. So it's 44 miles around. Sure, you can take this piece, figure what that is, here as well, this one here and here. Why do that? Just roll your pencil or pen. Now, it's possible that the test you don't use paper and pencil. That's a different conversation. But here you can visually see what we're doing. We have some glass tabletop. There's a pedestal. It says that it's 8 inches around and wider. And so it says, what is the perimeter of the glass tabletop? Okay, so that means that there's 8 inches here and 8 inches here, right? So the total here is 36 plus 16. That's what, 12, 3, 4, 5, 52. So this is 52 inches. And then here, let's figure this out. This little piece over here is another 8. And over here, this piece is another 8. This is 48. So 48 plus 16, right? 12, 13, 14, 4, 5, 6, 64. Now, there's twice these, right? There's 2 of these. So that's going to give you 4, 104. And there's 2 of these. That's 8, 12. And then the total, right, for the perimeter, 12, right, 3, 232, 232, which is E. Okay. All right. Here it says, Rob uses 1 box of cat food every day. Every day. No, every 5 days. Okay. 1 box. Days. 5. To feed his cat. Approximately how many boxes of cat food does he use per month? Well, every month approximately has what? 30 days? 2 boxes would be 10 days. 3 boxes would be what? 15 days. 4 boxes would be what? 20 days. 5 boxes would be 25 days. 6 boxes would be what? 30 days. 6 boxes, right? We would consider 6 boxes. Okay. Okay. That's basically, you would do it this way. This is one way, right, of doing it. Okay. Tara can develop 2 rolls of film in about 18 minutes, right? At this rate, how long will it take her to develop 8 rolls of film? Well, the same thing again. right? 4 rows would be add another 18, 16, right? 1, 2, 3, 36. And then another 2 rows, right? Another 18 minutes. That's 12, 13, 14, 3, 4, 5, 54. And then 8 rows, right? Add another 18. That's what, 12, 5, 6, 7, 72. 72 minutes, right? Here it has hours. Okay, so there's 60 minutes. There's 60 minutes, right? In an hour. That means I'm left with 12 minutes. So an hour and 12 minutes? An hour and 12, right? Okay. Yes, you can do proportions, which eventually we're going to have to do. So let's see. 2 is the same as 18, and I want 8, right? How much time, right? And I can reduce, couldn't I? 1 over 4. So 18 times 4, right, is, what's that? 1632, 4, 5, 6, 72, right, minutes. And then we would keep going and doing this. 60 minutes plus, which is an hour, plus another 12 minutes, right, which would give you this answer. So you could do these proportions, or you can just think it out like that. Okay, next one. Someone has a bag. Okay, this bag contains 18 black, 15 red, 11 blue, and 8 white. Liliana randomly takes a red marble from the bag and leaves the marble on the table, a red one, right? A red one. So there's still 18 black, and then there's going to be 14 red, is it? Right? Red, yes. 11 black, 8 white. What's the probability that she will next take a red or a white, a red or a white? So red is 14, white is 8, right? 14 plus 8 is what? 8, 9, 10, 11, 12. So 24, 22. 8, 9, 10, 11, 12, right? So there's 22 red or white out of how much? Out of the total? I don't know. 18, right? Black and blue, right? So black and blue, B, this one. Yeah, blue. Let's say that, blue. Black and blue, 8 and 9, 29, plus the 22, the rest of them, 9, 10, 11, 51. So there's 22 out of 51. There's 22 that are red or white out of the total 51. And we got it, D. Okay. Now, I might be going a little bit too fast. I might not be writing down, let this equal, let that equal. And why not? Because the time constraint, right? I don't know what the time constraint is at this moment in the CBEST, but we can probably think that if you start writing formulas and you start making it more formal, it's going to waste some of your time. This was more like thinking out of the box, and you're going to make mistakes, and then you correct them as you go along, and you try your best to do it, and then there's the answer. Okay, let's go to the next one. Okay, At a college, approximately 2 out of 5 seniors, right, attend graduate school, right, from college. There are 750 seniors. How many would you expect to graduate or to attend graduate school? Okay, this is a fraction of 750, right? So 5 goes into, so we multiply, right? We can multiply and then divide by 5, but let's reduce already. 5 goes into 5 once, and 5 goes into 750. How many times? I don't know. So this is 5, 1, 25, right? Which would be what, 5? And then we have a 0, 150. Okay, good. So 2 times 150 is 300, isn't it? Which will be the letter E. Okay, great. Okay, so here we have a library of a bunch of books, a million, more than a million. And then there's another library that has 907,000 plus books. Which of the following is the best estimate and how many more books the Mills library have? Well, this is going to be an estimate. So we're going to have to round. This looks like a million. The next one, the Springvale, looks like it's 900,000. Oh, I'm missing another 0. 900,000. Right? So it looks like I'm missing 100, well, not missing, but the difference is 100,000, right? 900,000, 1 million, that's a difference of 100,000. Okay, so we round these, or we round down, here, which of the following is the best estimate? Oh, great, best estimate. So this one is 4,000. This one is probably 400. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 4 times 4 is 16, right? So that's 1,000,006. Okay. This again is rounding down. This one's going to round up. If this was, I think, 4, 5, 3, 4, then you probably go up to 5,000. Okay. So this one is some trench that's below sea level at 35,840, and then above sea level, Mount Everest, a mountain, at 29,028. And it says the best estimate between the distance. Why not just add them, right? Let's see. Why don't you just add them? Why do you need to estimate? But this is 8, 4, 6, 8. That's 14, right? 34,868, which is, 64,000. Wow. 5, 6, 64,000, which is close to this answer right here, which is 65,000. Let's see. This is 36. If we round it, this is 29. 0, 0, 0. That's what, 15, 65. You see? Okay, so that's good. 15, 10th grade tests. Okay. So it's one of these that you have to think a little bit. So the raw score is 72. Percentile means that, this is 50 percentile. Over here somewhere is 88 percentile, meaning that they scored in this area right here above average. And then there are what? 20, no, 12%, right? 12% are above this person, right, Kim. This right here, I think is some type of ranking, 1 through 9. And then this is the grade equivalent. So supposedly she's reading 12th grade. So, Kim. Okay. He scored as well as or better than 72 of the test takers. Better than 72? No, that's not what it means. Well or better than 72? No. That's not what that 72 means. 28% of the test takers scored better than he did. 28%? No, 12% of the test takers scored better than he did. So no. He would perform adequately in the 12th grade science class. Yeah. I don't know about this word adequately. He scored as well as or better than 88. Yes, that's true. He answered 72% of the questions. Well, that's not a percent. I would go with D, and that is the right answer. Okay. Some of these are a little bit silly. Okay, so here's the expression, negative 105. A positive times a negative is a negative, right? So let's do these. When you have the same sign, you add them and you keep the sign. So this is what, 119. And then plus 34. So you're going to subtract. So that's 5, 1, 2, 3, 1, 2, 3. So that's 8, 85. Don't forget this negative. And here it is. The letter C as in cat. Okay, so what else do we have? 17. Use the information below. As part of the unit on weather, students record the outdoor temperature, 8:30 a.m. For 5 mornings. Okay, what was the difference between the week's highest and lowest? What is the difference, right? So in the number line, that's a horrible number line, right? 1, 2, 3, 4, 5, 6, 7, right? Tuesday, 7, 8, 9, 10, 11, 12. You can see that. Wednesday is 4, it's right here. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Negative 13, right? And then negative 15. So you can see it's from 15 to 12. Here's 15, and here's 12. I don't know, what is that? 27 degrees E, okay? So you can see it visually here, right? And you can see that the distances are there. Again, can you do it differently? Yes, of course. Okay. All right. Let's do number 18. Let's see. Okay. A teacher has 3 packages of stickers. One package contains 56 stickers, another one 48 stickers, and another one 58. If the teacher divides the stickers equally among 27 students, how many stickers, okay, do they receive? 56 and 48 is what? 12, 13, 14. That's going to be 10 plus another 58. That's going to be what? 12. 162. There's 27 students. Wow. 27 doesn't go into that evenly. So 27 and 27, that's 54. 54 doesn't go into 162. 27, that's going to be what? 11, 5, 6, 7, 8, 81, 27, 8, 8, 9, 10, 108. So this is 1, 2, 3, 4, right? 27 times 4 is 108. That doesn't do it here. 27, yes, I can take 54 over here and do it faster, but we'll do it this way. 14, 15, 135, 27, so this is 5. What's that? 12, 3, 5, 5, 6, 162. 6 times. 162, 6 times. So they get 6 stickers. Okay. What is the digit, right, that goes here? Oh, okay. This is going to be trial and error. 1, and then 8, 5, and the remainder of 23, which is important. Because I could put a 2 here, and then 125, right? But that's how many times? 25, 50, 75, 100, 125. That's multiplied by 5, which is correct, right? But this is not a remainder of 23. This is only a remainder of 3. Okay, let's do the next one. 25, 1 blank 8, right? And there's a 5 here. We know it's 125 because the next one is 3. And this will give me what? A 3 and a 1. That's not right. Let's go with the 4. With the 4, right? This 4 goes here. And then 8. That's going to be a 5 because it's 125. Then this is going to give me 3, and this is going to be 23, which we have, so it's 4. This is trial and error. You just pop in the number. The whole idea here is, do you know what this 5 means? Well, you need 5 25s to get 125. And then the subtraction, right? So trial and error. That's my advice. Again, test taking skills are important here in that you're not writing the theory or like the formula. Yes, when you study this, of course, it's important to understand the theory behind it, and a lot of the times you'll see that when working on these problems. But the thing here that I want to demonstrate is that when you're taking the test, you're thinking differently. You're just going, moving all the parts of your brain, basically. Okay, so last week somebody walked 7 miles and 3/4. This week he walked 15 miles. Wow, and 5-6 miles. 15, 5-6 miles. What is the difference between the distances that he walked? Okay. 15, 5/6, and then 7 3/4. So I would take these numbers. 15, take away 7, right? Borrow 5, 6, 7, that's 8. 8 miles. So we know that these are not right. And it's not going to be perfect, so it's between these two. It's not a perfect 8. So, so this is 5/6 plus 3/4 because we're subtracting, right? We're subtracting. That doesn't really matter, does it? No. We have to subtract because we're subtracting the 2. It doesn't matter where the subtraction is, I don't think. Let's see. It might matter. let me see, 5 over 6 minus 3 over 4. Okay, one way of doing this, 5 times 4 is 20. 6 times 3 is 18, and then subtract. 4 times 6 is 24, and that gives you 2 over 12, and then 1 over 6. No, this is 2 over 24, 1 over 12. There we go. This is the answer. Does the subtraction, let's see, 3 over 4 minus, yeah, well, what's going to happen is that you're going to get a negative 1 over 12. And you might think you might have to subtract it from 8. And that's not the case. So the subtraction does matter. Where you put where these fractions land, right? And the subtraction. So it does matter. All right. Well, that's good to know. Because we're trying to find a positive distance. Or you can change these numbers into improper fractions, which will take you forever. All right, so that one is messy in thinking, right? And you can always rewind it and listen to what I'm thinking about. The point is that these are going to be messy in your mind. All right, let's try this. A sporting goods store offers 10%. Great. Discount. And the skates are $110.99. How much will the skates cost with the discount? Okay. So 10%, right, is moving the decimal one place over. Like, for example, if you have $100, 10% means you move the decimal, you get $10. So move the decimal, you get 11.099. You got to keep all these numbers. This is the discount. So this is the price of the skates, and this is what you're going to get in the difference. So we're going to borrow a 9. This is going to be an 8. That's going to be 1. We're going to have to borrow here. That's the whole point. That's a 9. That's an 8. That's an 8. Borrow here. That's a 9. This is going to be a 0. And this is going to be a 9. 9989, which is A. See that? There's a difference of 10 cents here. That would be probably, see, this is 10%. Okay. This is why this is a little bit easier. Okay. So let's do the next problem here, right? At the beginning of a class period, right, half of the students in the class half of the students in the class go to the library. Okay, library. And I guess the other people stay in the class. Later in the period, half of the remaining students go to the computer lab. Class, lab, right? If there are 8 students remaining in class, how many students were there originally? Well, there's 8 in the lab, 8 here, 8 here. That's 16, 32. 32 students, okay? You don't need to do a formula or anything. Just write it out and go. Peter works 38 hours per week and earns $7.25 per hour. His employer gives him a raise that increases his weekly gross pay at $307.80. How much was the increase? So 725 times 38. Let's find out how much originally he earned. So that's 40, 16, 17, 18, 19, 20. Nothing wrong with using your fingers. 7 times 8. What's 7 times 8? Well, we know what 7 times 7 is. Hopefully it's 49. 49, 50, 51, 52, 53, 54, 55, 56. 56. 56, 57, 58. 58. Okay. That's an 8. Cross. This is 15, 6, 7, and then 21. 0, 5, 14, 15, 5, 6, 7, 2. If you don't know how to do this type of multiplication, you have to practice a little bit, okay? There are 2 decimal places, which is right here. So 307.80, right? And he earned 275.50, and let's do the difference. 0, 3, 2, borrow, right? Which will be $32.30, which is right here. Okay. All right. Okay. Let's do the next one. Use a diagram below. Okay. All right. Let's see. Package for shipping, wrapping tape. An additional 10% length of the tape package is needed to overlap. What's the total? Okay, so this is probably the tape, right? That goes around. We need, and then we need to add 10% more of that tape. So this one's 5, right? This one's 5. This one's 5. There's another 5, 5, 5. 5, 10, 15, 20, 25, 30. So there's 30 going up and down, right? And then there's things that wrap here. This one's 10, 20, 30, 40, right? And then you've got to go to the top. That was 15. There's 15 here, and then the bottom one, 15. So that's another 30. So that's 0. That's 7, 8, 9, 10. That's 100. And then we need 10% more. 10% more, right? Here's the decimal. Go here. That's another 10. So 100 plus 10, 110 total inches, which is here. Okay. Some people don't have the ability to do the geometry. That means you're going to have to redraw it, or you're just going to have to keep it in your mind. Either way, the faster you get to understanding the geometry, the easier it'll get in determining these numbers. Okay. Arturo is driving at a speed of 50 miles per hour. What does that mean? For every hour, he's traveling 50 miles. At 2 p.m. Okay. So at 2 p.m., right? 2 p.m., he's driving and he sees this sign, and he's at 50 miles. He's driving 50 miles per hour. If he continues at the same speed at 50 miles per hour, meaning every hour he's doing 50 miles, at 2:30, right? How far from Cannon will he be? Right here. Okay, how far will he be? So this is per hour, right? He's driven a half an hour, meaning that he's driven 25 miles already. From this sign, it said 62 miles from here. And then he traveled 30 minutes, which is 25 miles, right? And the city is over here somewhere at 62 miles, right? The question is, how much more does he need? Well, 62 minus 25. We'll borrow, right? 2, 3, 4, 5. That's a 7. This is a 5. This is 37 miles. And there we go, 37. No formulas, no x is equal to anything, just a little bit of common sense, a little bit, okay? The key here is that I know that for every hour, they're traveling 50 miles. And if they only did a half an hour, that means they did a half of this, which is 25, okay? Kiko spent the day bird watching, okay. And counted 34 more birds in the morning than in the afternoon. So this one you have to do an algebra. 34 more than in the morning. That means the morning he had X. No, 34 more birds in the morning than he did in the afternoon. Okay. All this is equal to what? 76 birds. How many birds did she count in the afternoon? If she saw 34 more birds than that in the morning. All right, so this is 2x plus 34 equals 76. Subtract 34. 2x. So this is going to be what? 2, 4, divided by 2. X is equal to what? 21. Okay. All right. Solve for y. Y minus 2 plus 3y equals 10. Right? This will give me 4y minus 2 equals 10. Add 2. 4y equals 12. Divide by 4. Y is equal to 3. Okay? Now, if you can't do this, then plug in the answers. And hopefully you'll have enough time to do that. If you plug in 3, let's say you plug in 2, right? We know that's the wrong answer. Let's plug in 3 minus 2 plus 3 times 3 equals 10. 3 minus 2 plus 6. Does that equal to 10? This is, 2, no, that's right. This is 9. That's 9. Look at that. Okay. So, 9, 10, 11, 12. Take away 2 equals 10. 10 equals 10. Wow. See, little basic stuff like that can kill you. So you got to be a little more into it. All right, let's try this. So a refrigerator in a school cafeteria is partially filled with 42 sandwiches. Okay. There are 13 turkeys, 4 turkey sandwiches, 14 cheese sandwiches, and 15 egg sandwiches. By the end of the lunch period, 21 of those sandwiches are sold. So half of them are sold, right? You started with 42, they sold 21 of them. You don't know which of these, okay? So, which of the following fact can be determined from the information? The number of cheese sandwiches are sold? No, we don't know what was sold. The cost of the turkey sandwich has nothing to do with price. The total number of sandwiches can be placed in the refrigerator. The total number of sandwiches can be, well, yeah. So that's not an answer. The total number of sandwiches when? After or before? The total dollar sales? Nope. The number of sandwiches remaining in the refrigerator? Yes. Okay. A little common sense goes a long way. Okay, number 29. Okay, we got 21 more to go. We can do this. Let's see. Jen and Sue are going to drive cross country to reach their destination. They plan to drive 400 miles each day for 5 days. So this is per day. This is a day, 5 days. That's what 5 times 4 is 22,000, right? If gasoline costs an average of $2 per gallon, $2 per gallon, approximately how much money should they budget for gasoline on the trip? Well, let's think about it. They're going to go 400 miles, right, per day. Gasoline is $2 per gallon. The only thing is we don't know the car. Like, does the car do 2 miles per gallon? I don't know, right? We don't know. Or does it do 100 miles per gallon? We don't know this value because we don't know what type of car. Are they driving, a big truck which spends a lot of gas or not? So, which single piece of information is necessary? Let's find out. The number of times they will have to stop for gas? No, we don't know that. The number of miles the car travels per gallon. There it is. Yes, that's the one. We need to know, right? The number of miles Jen will drive? No. The total distance of their trip? We already know what the total distance. The number of miles the car travels per hour. They could be traveling 60 miles, 80 miles. We don't want to know that. We want to know how many miles per gallon. Okay. Let's go with number 30. Maria left her home at 9 a.m. Okay. Ran 3 miles to the lake. Right? Ran around the lake twice. Wow, twice. And then ran home along the same route, another 3 miles. For a total of 10. So 3 and 3 and 6 miles. So I guess 4 miles. 4 miles, right? This is a 2 mile. 2 mile plus another 2 miles. So what? What was Maria's average jogging speed? The thing is, we don't know what time she came back, right? The thing is, average speed. Speed is miles per hour. We know how many miles, 10, but we don't know what time she came back. So which single piece of information do we require? The distance? No, the lake, we already know that. The time she returned home, yes. The amount of time she stopped for rest? No. The average length of jog stride? No. The amount of time it took her to run around the lake? No. It's the time that she came back. Oof, okay. All right. And some of these, of course, you can be there for a little while thinking about it. So Antonio buys 4 notebooks for $3.50 each at a store. Next day, he returns to the store and exchanges the notebooks for 3 notebooks that have gone on sale for $175. Antonio uses the following expression. Which of the following expressions could Antonio have used instead? Ugh. Okay. So this is all about basically manipulating the algebraic, what is this called? Algebraic, the whole idea here is to rearrange the algebraic expression. So the 4 and the 3 are important because they're returning 3 notebooks, right, at $1.75. So here, we don't have the notebooks, so that's not right. Here, this is 12. Where do they get 12? It's not 4 times 3. There's not 12 notebooks. And over here, it looks like they have, you know, again, this is 12. You don't factor these out. This is 4 times, let's say 4 times 3.5 minus 3 times 1.75, right? These are not the same, so you can't factor those out. And these, you can't factor these out like they did over here, and this is 12. Over here, they have 4 and 350, but they don't have the notebooks, so it must be this one. How's that? Well, it seems like 3 of them, right, were 350, and then you're going to take away 175 from them. But there's one notebook that's left at 350. Okay, and this is it. Rudy needs to calculate 14% of 50. He does the computation this way. Which of the following method could Rudy also use? Well, let's see. 100 take away 50? No, there is no subtraction here. 50 divided by 14. No, but where's that 100, right? Where did this 100 go? There's no decimal here. 14 over 50. Well, these are on the same line, so that can't be. 14 divided by 50. No, 50 times 14. So it must be this one. 14 divided by 100 is 0.4. 14. And then 50 times that is it. Okay, so again, it's through elimination, okay, by doing the numbers. All right, let's continue. Okay, let's continue. Number 33. Use this table, average, quiz average, test average, final exam. The table shows Sabra's grades for a class. For her overall average, the test average counts twice. The test average counts twice as much as the quiz. Okay, as a percent probably, right? And the final counts as twice as much as the test average. Twice as the test average. Okay. Find the overall average. Sabra uses the following expression. Okay. Twice as much. Okay, so what happens here, let's see. One, two, three, four, five, six, 7. There's 7, so it has to be divided by 7. This is not everything is divided by 7. This one doesn't seem to be divided by 7 at all either. And divide by 7, that's 1 over 7, is not 0.7. It doesn't translate to that, right? Let's see. Right. Right, it does not. But here is something interesting. The quiz is at baseline X. The test is twice as much as the quiz, and the final exam is four times. So this is 1, 2, and this is 4. And this is where we get 1, 2, and 4. But this doesn't make, this is divide by 7, not divide by 0.7. So that's not right. And this is divide by 7, not divide by 1 over 7. And here's another thing too. You can see that there's 2 of these and 4 of these. That's why it's done that way. It's just the expression is different. And this one is multiplied by 1 over 7, which is right, because this is, this whole thing, right? Let's call this Q. Q divided by 7 is Q multiplied by 1 over 7 is Q over 7, right? Let's pretend this whole thing is Q. So this is it. So that was a little bit harder. You probably didn't have to do this because it does explain it there. So just by looking at the numbers, because which of the following way to find her overall, which of the following is another way, right? And I guess you could just look at what you have, right? You have 2 of these, you have 4 of those, and you might say, oh, division, right? One of these 2, but it's divide by 7, and none of these are divide by 7. And this is a little trick that they're doing here by multiplying. Okay. Wow, that's a brain twister. Okay, use the chart. The chart above displays a relationship between x and y. Given this relationship, what would be the value of y, right? That's missing. All right, so here it's half, here it's half, here it's half, here it's half, here's half. It's consistently half. Here we got 1.5, 1.5, and 1.5 here will be 7.5. 1.5, yes, 1.5. There we go, 7.5. It's proportional. It's a line, right? That you have. This is y, this is x, and this line is proportional. Okay, it's linear, and it's linear. It's a linear. It's proportioned linearly. And we'll just leave it at that. The school district is proposing 5% increase in the days. Okay. Currently, there are 180 days in a year. How long would a school year last with a proposed increase? Wow. So 180 times 5%, right? 5% means 5 divided by 100, which is 0.05, okay? That's one way of doing it, and then, well, let's do it. 0, what's that, 40, 5, 9, x, 0, 0, 0, 0, 0, 9, 2 decimal places, 9 more days. 9 more days. So it'll be 189, right? Now, check this out. 180, right? What's 10% of that? That's 18 days at 10%. But we only want half of it, which would be 9 days. And that's 180 plus 9, 189, right? Okay. All right. 36. Okay. Ooh, so which of the following mathematical statement is correct? So I think we're gonna do these mixed numbers in improper. So because these all have the same denominator. That's 9, 10, 11 over 3 less than, what's that? 9, 9, 10. Is 11 over 3 less than 10? So forget about this, right? With the same denominator. Is 11 less than 10? No. Okay. Let's do this one. That's what? 9, 10, 11, as before, over 3. Greater than what? 6, 7, 8 over 3. Is 11 greater than 8? Yes. 6, 7 over. Is 11 greater than 8? Is 8 greater than. Is 11 greater than 8? No. Is 11 greater than 8? No. Ooh, okay, good. I said yes, didn't I? No. 3 times 3 is 9, 10 over 3. Greater than 6, 7, 8. Is 10 bigger than 8? No. Okay. 3 times 3 is 9, 10, 11. 11 over 3. Bigger than 9, 10. Is 11 bigger than 10? Yes. All right, let's keep going. 3 times 2, 6, 7, 6, 7, 8 over 3. Same denominator. Is 10 bigger than 8? Yes. Okay, that's the answer. And you go on. All right. Which of the following values, when entered in the box, will satisfy the statement? 2 over 6 is greater than something greater than 6 over 8. Let's reduce. 1 over 3. 1 over 3 less than 6 over 8. 2 goes into 6 3 times. 2 goes into 8 4 times 3 over 4. And these are reduced. So 1/4. So this is 1/3. This is 0.333. This is 0.75. I know you might not know that is. You might have to do division to figure that out, because when you have decimals, it seems to be a little bit better. But look, is a quarter, right? This is 0.25. Is a quarter bigger than is a third less than 0.25? Is a third less than 0.2? No, it's not. Okay, this is a third. Is a third, you can put a bar. Is a third less than a third? No, it has to be less than or equal to a third. Half. Is a third less than half? Yes. Is a half less than 0.75? Yes. That's it. That's the answer, and you go. You can check the other ones if you like. Okay. Remember, thinking about it as a test. You don't need to check the other answers. You're done. Okay. We're almost there. Which of the following mathematical expressions is equivalent? BH over 2. So this is BH over 4. Nope. This is 2BH. It's not the same. Nope. This is, you add B plus H over 2. Nope. This one is half of BH over 2. Yep, this is it, right? And you're done. Which of the following number is between 2329500 and 2598100? Okay. In between, right? In between. This is 22, 23, and 25. Nope, that doesn't fit in there. 23, 23, 23, 25, 8. Okay. Actually, look at this one. 25, 8. 25, 8 is below here, and it will be between. There are no two numbers that will be between these. There's only one answer. And you can check this if you like to see, and you'll note that it won't fit in between. Okay, that was pretty neat. Again, elimination. So I saw that 25, 25, yeah, but that's an 8. That's a 9. This number's bigger, and you want to go below this so you can be between. And 25 is bigger than 23. Okay. If the value of x is between these two numbers, which of the following could be x? Okay. 0, 0, 5, 1, and 0.0380. Okay, think about this. This is about 3 cents. Make that 4 cents. And this one is not even a penny. If you round it, it's about a penny. Okay, anyway. What's between here, right? So you're going from a penny to 4. This one is 42, right? This is 2 zeros and a 5, 1. This is a 2 zeros and 42. Doesn't fit in there. This is basically 3 cents right here. See that? That's going to work, and that's all we need. 3 cents right there. This one, you can see, is 5 cents. That's way above what we need. This one's 5 cents. This one's 6 cents. See that? Yes, I know. That's not what you do. You know, it's, I don't know, tens, hundreds, thousands, 100,000s, 4,200,000s or something. I'm not going to get into that, right? I'm not going to get into, like, mathematically what it is. I can see it here. This is about, if you round, that's about 1 cent. This run you round is 4 cents, and then you just do it. That's all you need to do. Nobody's going to look at your math. The thing is, can you think logically? And I think you can. Okay. So we need 10 more. Abby drives 18 miles around trip between home and work each day. 18 miles. 9 miles. 9 miles. Right? Home and what? And work. If her daily round trip, if her daily round trip is rounded to the nearest 5 miles, which would be 20 miles instead, right? Because here's 0, here's 5, here's 10, here's 15, here's 20. These are multiples of 5, and here's 18, so we're talking about 20. What's the best estimate for the total miles in 5 days? Times 500, right? Which is B. Next one. Carrie ran the same distance in 4 different races. Carrie ran the same distance. Her times were 18.04, 21.39, 12.99, and 14.14. The individual times rounded to the nearest 1/10 of a second. Oh, great. 1/10. 1/10 of a second. What is the estimate? Rounded to 1/10. 1/10 is, if you think about it, like in money, right? What's 1/10 of a dollar? 10 cents. A tenth of a dollar is 10 cents. So we're talking about this right here. This is tens, hundreds. So we're going to round. We're not going to round. Oh, we're going to round. Well, that's still going to be a 0. We're going to round. That's going to be a 4, probably. We're going to round. This whole thing does. This is 13. We'll see if this is right. We're going to round. Right, that's a 4. So that's 14. 0.1. So that's a 5, 8, 9, 10, 11, 12, 13, 14, 15, 16. 2, 3, 4, 5, 6.5. Yep, here it is. Okay. Definitely that one you needed to know a little bit about, the positioning of the points. But again, I changed the problem. These are what? I don't know. These are in seconds. I didn't think of them as seconds. I thought them as money. Can you do that? Of course you can. Why not? It's easier. Because we deal with money more than people that are running. Okay, this one. Let's see. The grocery store located 3 miles away from the house. Here's the house. Here's the grocery store, right? But the grocery store can be here and here and here, right? Or there, or there, or there, or there, right? The grocery store could be anywhere in a 3-mile radius. 3 miles. Sure, you can zigzag and all that, but it's within the 3. And then the next one says, the house is located 4 miles away from the highway. Okay. So 4 miles. Somewhere around here is the highway. Right? This is the highway. This is the house. So it says, okay, the grocery store is no more than 3 miles away from the highway. We don't know that. No more than 3. We don't know. See, here's the grocery store, and here's the highway. This could be 3, and that could be 4. That would be 7. The grocery store is no more than 3 miles away, so that's not true. See, that's 7 miles. That's a 7-mile distance. The grocery store is no more than 1 mile away from the highway. That's not true too, because here's the grocery store, here's the highway. So that could be, again, that's the maximum distance that it can be. We don't know if it's no more than 1 mile. The grocery store is no more than 7 miles away. That's true. No more than 7. It could be 7, but no more than 7. Yeah, that's right. That's it. We're done. Because the grocery store is exactly 3 miles from the highway? No. The grocery store is exactly 4 miles from the highway? No. The thing is, we don't know where the grocery store is or the highway, but we do know the maximum distance between the two. Okay. All right. 44. Okay. If the distance to the destination is greater than, if the distance to a destination is greater than 10 miles. All right, I don't know. Let's say this is home. This is the destination. 10 miles. 10 miles. Okay, yeah, it is home and destination. Then Matt will drive his car. All right, he'll drive his car. Fine. If the distance to the destination is greater than 2, this is, let's say, 2 miles, but less than 10, right? Less than 10. Then what is he going to do? He's going to ride his bike. Okay. If the distance to the destination is less than 2 miles, then he'll walk. Okay, so it's less than 2 miles. He'll walk. More than 2 miles or less than 10, he'll ride his bike. If the destination is greater than 10, greater than 10. All right. If Matt rode his bike to Zach's apartment, which of the following statement is true? Okay. So he rode his bike. So we know that it's within, what is that, 8 miles? Right? This is 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's within 8 miles. What else do we know? It's going to have to be greater than 2 miles. So what is the answer? Matt's home is less than 1 mile from Zach? No, it can't be. He's riding his bike. Matt and Zachary live within 2 miles from each other. It can't be, because he's using his bike. Zachary's apartment is about 7 miles from Matt's home. Possible. Zachary's apartment is at least 10 miles. At least. Right? What does that mean? Well, what about if I told you, at least take out the trash? That means it has to be that or more. So it says at least 10. Well, at least 10 means more than 10. No. The round trip distance between Matt and Zachary is greater than 20. Can't be, because the distance here is 8. So it's C. Okay. Wow. That's a lot of talking. Okay. It says right here, if it rains, so there'll be a softball practice every Saturday throughout the season, with the following exception. If it rains, softball practice will be canceled. Okay, if it rains, no practice. There is no softball practice on the third. No practice on the third Saturday. All right, Saturday. If it's Saturday, but there is no softball practice, then what is true? Well, what is true is that it could be raining, or it's the third Saturday. Do we know the third Saturday? No. Do we know it's raining? No. It's raining. Yes, it could be raining, but is it the third Saturday? We don't know. Right? Right. It is the third Saturday of the month. Well, we don't know if it's raining. It is raining, and it is the third Saturday of the month. We don't know that. We don't know if both are happening. It's an or. It's raining, or it's a third. There we go. That's what we need. The softball game is on the third Saturday. No, it's not. Okay, there it is. Wow. All right, let's keep going. Middle school. What is this? Use the table below. Class periods, starting times, ending times. Well, let's look at this carefully. From 40 to 36, right? So if you look at a clock, right? Here is 40, and then it's at 36, right? It went, it's about 40, 1, 2, 3, 4, was that 56 minutes, I guess? Okay. And then between here, what do we got? We got 4 minutes. 4 minutes. From here to here is another 4 minutes. From here to here is another 4 minutes. And we assume from here to here would be another 4 minutes, right? So that would be 12, 19, you would assume. So let's see. The partial school schedule above shows the start times and the end times of the class. Except for lunch, all classes are the same length. Okay. Except for this one, which it is. It is different. But it doesn't say that the between the classes are different. What is missing? What is the missing start time for the 5th period? 12:19. Right? It does not say anything about between the classes. And lunch, we'll call that a class. Okay, done. Wow. What do we got here? We got years, United States, world. How many metric tons of silver were produced outside of the United States in 1950? Now this says world. How many metric tons of silver produced outside the United States? 6323. Yeah, it's here. Look at that. Well, the United States is part of the world, so most likely we're going to have to get rid of the United States to get the rest of the world. 3, 4, 5, 6. 3, 4, 5, 6, 7, 6. That's a 1. 1, 2, 3, 4. That's a 7. That's a 2, right? Wow. 1, 2. That's a 9 and a 5. 5, 9. Is there a 5, 9? Did I mess up there? That's a 5. Oh, that's a 4. 4, 9, 7, 6. Okay. If you're seeing me like, why am I counting? You see, if I have something like 9 take away, well, let me see, no, 13 take away 7, let's say, right? And then over here, you can count up 7, 8, 9, 10, 11, 12, 13 will give you 6. But also what you can do is, if you have 13, I don't have 10, I only have 10 fingers, thank God. So, do I have, where would I get 13? There would be 3 more invisibly. So I would take those down, 3, 4, 5, 6, 7. It gives me 6 as an answer. Okay. If you're just curious about what I was doing there. Okay, let's keep going. Use the graph. All right. According to the graph above, what is the maximum difference in energy consumption? So for this year, between the two sources of energy, in any of the years shown. Okay, so here's this one. So from here to here, it looks like 2.5, no wait, almost 2.5, right? In difference in BTUs, energies. These are in BTUs. 2.5, maybe this one, maybe. Is there anything else that's different? Here, that's a 2, that's almost about a 1 difference. Here, that's like a half a distance. Here, that almost looks like a half, like 0.4 or whatever. And then here, that's 1, 2, 3, almost 3. Bigger than that one. Probably 3.2 as an answer. Okay, an estimate. You don't need to know what BTU is, right? British thermal units. You see, it says right here, according to the graph, what was the maximum difference? This is the distance that we're looking for, the distance in energy, not the distance in the years. Years, you should know what that is. And then finally, the last one. And the last one says, use the chart below to answer the questions. Use the chart below to answer the questions that follows. What % of the total crop yield did the central farm generate? or this one. The whole thing is 100, so it's 24 plus 21 gives you 45. Plus 7, that's what? 10, 11, 12. That's 52 plus 31. That's 3. That's 8. So we need another 7 and another 10 to give you 17, right? You're like, what? Just do this instead. 10, 9, 10. That's what? 7. And that's a 1, 17. Okay. Wow. That's it. That's the test. So, as you can see, a lot of them were just, basic addition. This one, adding the totals and dividing to get a fraction, right? I don't think I'm going to do it all, maybe. This one, they wanted you to see if you can see the ends right here. This one's different units. This one, to see if you can visually see that there's another 8 there, right? This one is proportions. This one over here. This is again proportions. This one is statistics, but what you took one ball out, so it has a different denominator. This one seems to be a fraction of a number. This one's about rounding. This one again is about rounding. This one's 1, 2, 3, 4 numbers, right? So you round accordingly. This one is also rounding, but here I just added the real numbers, and because see these answers are pretty close, and we were right. This can catch you off guard. This is not 72%, as you can see. We don't know what a 12th grade equivalent is, and so forth. This one, a positive times a negative is a negative. This one, if you draw a number line, you can see the distances because it's really just distances. Here is about adding and dividing. This one is just plugging in and finding what that number is. This one is about fractions. Remember, fractions are your friends. This one's 10% discount, but did they give you a nice number like 112? What's 10% of that? No, they gave you some change. So you got to be a little bit careful with the math. This one is about, half of a half of a half, sort of. This one is about, can you multiply fractions, not fractions, decimals, right, with numbers. I know that this is not new math, but I'm old school. This one, can you look at a three-dimensional object and look at the tape? This one, do you understand the whole thing of rate equals distance over time? That I did not write this formula out and not write a whole bunch of formulas to figure that one out. And just common sense. You're driving 15 miles for every hour, and then half an hour later, you drove 25 miles, and then draw a line. This one's a little bit harder. This is one of those algebra tricks. This one, more algebra. It's not too hard. This one's a little bit logic. You don't know what you sold. You don't know the price. So what else do you know? This one, same thing. I did not have to have rate equals distance over time. Sort of common sense if you have a car. You need to know how much fuel this car spends. This one's about drawing a picture in the lake, and then you don't know what time they came back, so you don't know what the average speed is. And then this one, you got to look at each one. This was a little bit hard to do. But the idea is that he took 3 out of the 4. So you can't factor these numbers out. This one, you got to do each one to see how it looks, to see if it's the same equivalent. This one, you know, I took 1x, 2x, 3x, 4x, but you can see mathematically what's equivalent. That's what it really is. This one's basically proportions. You don't need to know about anything regression. This one, same thing, shortcut. You know, 10%, 18, half of that, 9. This one, you know, from mixed numbers to improper fractions, and then the bases are the same. The denominators are the same, so you just look at the top. This one, you plug in the number, but then reduce. A lot of basic, right? A lot of basic math. Knowing your multiplication tables definitely helps. And knowing some of the rules. You don't need to know, you know, multiplication rule, any of that. It's already built into you. You don't need to know the rules. Here, which one's equivalent? So you have to kind of like do the math. This one was pretty straightforward. This is, I only had to look at two numbers, 20, 22, 23. This is 22, that's below. And this is 25, 8, 25, 9, so it's below this one, it's between. And that was the answer. This one's sort of the same thing. And so I was thinking about money, right? So this is $1.38, right? These are cents, right? 2 zeros, but this is a 5. That's about 1 cent. That's why I thought of it that way. There's nothing wrong with thinking these problems being different than whatever they're talking about. This is about the nearest 5, right? Nearest 5. So I'm guessing, what about if it was a 4, right? Or a 3 or a 2? I'm not sure about that. Nearest 5. Round, oh, it says round. Okay, round, so you go up. Here, these are seconds. I didn't think of them as seconds. I thought of them as money. 1/10 of a second, or 1/10 of a dollar. This one is about, you don't know where the grocery store or the home is, so the maximum distance we know from G to H, max, is going to be what, 7, right? Was it 7? Something like that. This one, again, drawing it out, understanding like, hey, this is 8, can't be 20 miles round trip, and so forth. What else? Every Saturday, this is an or. We don't know it's raining or it's the 3rd Saturday. This one's about the time and the patterns. And this one says the same length in classes. It didn't say nothing about between the classes. I know. And in this one, the whole world, right? The United States is in the world. And this one, you have to draw like the spaces between. I don't need to know anything about nuclear or hydroelectric or what they do. I'm just looking at the difference. I didn't need to know even what BTU was. And in this one, it's a question mark. We know that this whole thing is 100. And I didn't need to know if it's South Farm, East Farm, or anything like that. Wow. That's a lot. That's a lot of thinking. Yes, I did go fast. And the idea here is about my mind just, you know, free-flowing and thinking. Not everybody can do that, especially if you're rusty in your math skills. There is another video like this somewhere on YouTube that they go really, really slow. And this is great. You can learn a lot of the concepts there. But this one is not about so much concepts. It is, but more kind of like a little bit of a trial and error using the answers in the test, test-taking skills. I hope this was valuable. Please tell your friends. Please tell your teacher about it. I hope you have a wonderful semester, and I'll see you later. Bye-bye.